Hey there, year 11s. This example here is probably more similar to what you would do next year, probably just a bit easier version, but essentially you'll always need to find the inverse function and then state its domain and range. That's a given, right? It always helps to find the domain and range by simply sketching the original function. So here we go. I'm going to start off by working with what I've got. I've got f of x, which is x over 3 squared. Okay, interesting. That becomes then x squared over 9, which is the same thing as saying 1/9 x squared. Okay, so it's quadratic. It's a quadratic equation. I have from 3 to 6. So if I were to picture this in my mind, you can use a CAS, by the way. When I do this, I'm thinking it's a parabola, doesn't move left or right, doesn't move up or down. It probably just looks something like this. But it has a restriction from 3 to 6. So say 3 is here, and then say 6 is here. Then that means I only sketch this part of the graph, right? So that means that's the only part of the quadratic that I'm going to get. So I need to know the endpoints. I need to know when x is 3, whoops, I should do it in red, what is the y value? And when x is 6, what is the y value? So here we go. I need to find f of 3, which is 1/9 of 3 squared, which is 1, okay? And then f of 6 squared is 36 divided by 9. So 1/9 times 6 squared, 36 divided by 9 is 4. So that tells me that this must be at 1 and this must be at 4. Okay, so I've got my graph there. I've got a rough estimation there. Now, I want to answer the question. So clearly, if I were to do the domain and range, this is pretty easy because I can see the domain and range. See, that's what I mean. You have to know how to sketch. So function and then inverse. Clearly, I already got my domain. The domain is from 3 to 6 is what they told me. And then the range is clearly based on the graph. It's this section. This is how much of the range I'm going to work with, between 1 to 4. So my range must be 1 to 4. But that means using the properties that we know of inverse functions, this must be 1 to 4 for the domain of the inverse. And then the range would then have to be the domain of the function, which is 3, 6. Okay, so I've answered the second part, state the domain and range of the inverse function. Now what's the inverse function? Well, if f of it, I would say let f of x equal to y, and that would then change it to y equals to 1/9 of x squared. And so I would then say, now to find the inverse, okay, so find inverse, we would do xy becomes yx. Okay, so I'm swapping the x equals y and y equals x. That means my equation now becomes x equals to 1/9 of y squared. Sorry, I shouldn't do that brackets, otherwise it confuses you. And then here we go, we're going to rearrange it, times 9 on both sides, and I will get now 9x is equal to y squared. Square root both sides, so y is equal to the root of 9x. Now remember, when you square root, technically there's a plus and a minus answer. Now this is interesting because that implies, this is my inverse function, so therefore inverse function is equal to the root of 9x. Now, there's a plus or a minus answer. So this is where you got to be careful. Okay, so which one is it? Is it going to be the positive of this root, or is it going to be the negative of this root? And the best way to know, okay, is looking at the range and the domain that was given. So the way I like to explain it is, if I asked you to sketch y equals to the positive of root 9x, what does that look like? Normally, you would then say starts off 0 and it goes like that. True? Or if I asked you to sketch the negative version of it, you would have said it looks like this. True? But clearly, in both cases, the range is different. The range for the positive version, the range would be from 0 to infinity, whilst the range for the negative version would be from negative infinity up until 0. True? So looking at the domain and range for the inverse, can you see that the inverse is 3 to 6? So which one does it fit in? Clearly, it fits into this one. That's why I know the answer has to be, the inverse function has to be root of 9x, because that's the only way that you're going to get it. Okay, so this is important for year 12 because they do want you to realize that it could be a plus or negative. Most times in the exams, they give you the negative version because they want to see if students check the domain and range to see if it works. So that's a little tricky there. Actually, maybe I should leave it there to remind you guys what to do there. So this is the root 9x version, and this is the negative root 9x version. Okay, so this is my correct answer for the inverse, and the domain and range I already got, so I've answered it. They didn't ask us to sketch, but essentially when you sketch it, everything will switch around. Okay, so you'll look more like that in a way. Okay, because again, you're going to work from 3 to 6 on your range, and then you're going to work from 1 to 4. So you'll find that, oh, actually, it might even be like that, actually. Might be more like that. No, 1 is over here. So maybe, yeah, 1 to 4. I didn't draw it to scale, so this is probably a bad way of doing it. Yeah, I didn't draw it to scale, so it won't help. But if I help you to visualize it, we can sketch both of them so you can see. So let's do Control I. Let's sketch the first one, which we knew was x over 3 squared. Okay, but let's give it a domain. So the domain was 3 to 6, right? So 3 x is less than 6. So that's the part of the graph that I drew. And then the inverse, okay, the inverse is, we worked out to be root of 9x. It was the positive version. But we've got to give it a domain. And we know that domain, if you remember, was 1 to 4. So 1x 4. There you go. So you can see there I overestimated because of my domain. My scales are off, so that's why it looked like it was going to cross through. But that's the mirrored image right there that you can see. So I'm just going to print screen this just to help you remember what you're actually doing there. It should be a mirrored image. And there we go. I'm just going to paste it over here to help you visualize the part of the root. That's why I knew it was going to be the positive version of the square root. Okay, so it had to be this one, which is the one I highlighted up here. Okay, there you go. So that's how you do example 22. It's a very typical question to do for year 12, but normally it's a bit harder in the sense that you'll likely have to decipher which one you draw based on the domain and range.